student. And I like to tell people I actually struggled the most with the Chem Phys section. Okay? So when going through this, all right, what we want to start to see is that there's 3 different of these strategies applying knowledge of functional group properties and nomenclature from that pesky organic chemistry that we definitely want to take a look at. Okay? So yeah, for some of you guys who are asking if you haven't taken Foley 5 yet, it might be best to actually come back to the archive version of this because we are going to go through a few different passages that you guys will be seeing on your full-length exam. So if you want to keep that as realistic as possible, I would definitely recommend and come back to Foley 5 at a later time. No problem at all, though. I see a lot of you guys going through. We're going to look at some really big areas of opportunity here. So learning goal number 1 is going to be super focused specifically on eliminating wrong answers quickly using logic and clues within the question. Okay, and for those of you guys wondering, yeah, Chuck is going to load in that PDF real quick. Sorry about that. Now, when working through this, how many of you guys remember passage number 1? Did anyone happen to skip passage 1 and do it later on and not do it in the order, similar to the triaging strategies that we talk about here, Captain? I know I did. I did not do passage number 1 first. And especially when looking back at this, I feel like passage number 1 is one that is a good thing that I skipped going through because I actually can then come back and go through this passage and maybe work through a little bit quicker. Okay? Now, as we work through a passage like number 1, it says the Earth's atmosphere, the layer of gases surrounding the planet Earth, reaches hundreds of kilometers above the surface of the planet. Okay? It goes through this whole thing. The atmosphere protects life on Earth because it absorbs UV radiation. Then in that second paragraph, the lowest layer in the Earth's atmosphere, the troposphere, extends, etc., etc., etc. Now, question, guys. Does the MCAT directly test you on like the troposphere or the layers of the atmosphere around planet Earth? Is that something that we would find like on the AAMC blueprint or even in our Kaplan review notes? No, probably not. Good, Colin Rucky. Excellent. Yeah, and this is why I always look at this and I kind of shudder because I think to myself, man, I made a lot of mistakes through my first full lengths when I really could look and say, okay, there's not a ton of information here that I find particularly important, except maybe talking about an adiabatic process and then the density. So it says air pressure within the troposphere decreases with height above the ground. But think about it. Let's just go back to our basic chem, because what we want to do is combine as much prior background content knowledge with our understanding of what's being talked about in the passage. What happens to air pressure as you increase in height above sea level? I know, it's a very simple question. Just want to make sure we're doing a good review here. What happens to air pressure as we increase our height or increase our distance from sea level? Air pressure is going to go down. So if anything, isn't this just restating something that we already know? Absolutely. So what I would put in for my passage outline here, and this is kind of a theme that you guys will see quite a bit in Chem Phys, and something I definitely like to take away from, is I wouldn't even put that much information. I know that I have background information on the Earth's atmosphere, so technically in this spot, I might even just write down Earth's atmosphere, and then in paragraph 2, I would just say density, and then I put a down arrow as we go higher in the atmosphere and be done. Is there that much discrete information here that the MCAT's going to test? Absolutely not. But that's the key. I like to always call this fluffy information. It's information that we actually don't really need to know, but it might lend us maybe an insight into some of the questions. Now, of course, anytime we see a figure, table, graph, chart, or equation, we want to be picking up some key information here as to what's being asked. Now, what it does tell you is the pressure, the temperature, and the altitude in the Earth's atmosphere. But now it starts to get into a little bit more of detail. So what would I put in my passage outline for this figure in this paragraph? Probably just the relationships between temperature, pressure, and altitude. But I'm not going to write down much more than that because what I really want to make sure is that I'm pulling relevant information in the passage that's going to help me answer more questions correctly. Now, if you work through then, it just talks about a smokestack. Again, a smokestack isn't something that you have to memorize for test day, but what it's talking about is it removes heat from reaction mixture, and it gives you an overall equation, where Q is the heat, I is the gas, N is the number of moles, and Cp is the molar heat capacity of a particular gas constant. Hold on a second. The good test takers that we are, is the values for like Q, T, enthalpy, entropy, H and S. Are those values going to change between now and the time you take your test? Think about it. And what's kind of fun here, guys, is we have a little bit of a smaller group in this session here, so definitely don't be afraid to ask questions and type in the public chat. There's only about 6 of us, so please fire away and don't be afraid of making mistakes in the chat. Good, Marenki, you're absolutely right. No. So when I get through this, let's try to get into these questions as quickly and as efficiently as possible. I don't want to spend too much time in the passage when I can go up and pick up quick questions. Now, let me ask you guys, just before we jump in, because I want you guys to think big meta concepts here. Does anybody struggle with their timing in the Chem Phys section? Anyone struggle with their timing? I'll raise my hand, probably the highest. I was the one, yeah, cool, Renki, I struggled a ton in the beginning with timing. But what I realized is one of my biggest downfalls personally, and I always love to pass this on to students because I think it makes a big difference, is I spent way too much time going through the passages and analyzing. When I started to look back, and Chuck can probably say the same thing, I realized that more questions in Chem Phys than probably in any other of the sections ended up being kind of pseudo-discrete questions. Now, how many of you guys, if you look back at number 1, think to yourself, well, wait a second. The decrease in temperature of a parcel of hot air rising from a smokestack is a result of what? Did you have to understand that much information from this passage in order to work through a question like number 1? No, probably not. But let's think about this. Based upon the passage, what type of process did the hot air undergo as it was rising? As it was rising, what type of process would it undergo? Think about this. This is straight from the passage. This is really the only tidbit of information, because if we pick this up, then you can pull away a lot of that power background content knowledge to help you in this question. Cool, excellent job, sir. So that's the coolest part about it. What do we know about an adiabatic process? What do we know about an adiabatic process? There's no heat loss. So what we say about adiabatic expansions is even though the volume is increasing, there's no heat transfer. Now wait a second, guys. If there's no heat transfer, can we go through and easily eliminate quick answer choices, making a question that might have originally seemed kind of intimidating a really simple question? Check this out. Can you have any heat loss to the surrounding cool air? Well, if there's no heat transfer, boom, I just got rid of A and B. Now wait a second. If there's no heat transfer, can you have an increase in kinetic energy? If it's an adiabatic process, no. Well, guess what? I'm done. I literally can go through just by that process of elimination, and I know in a quick and efficient manner it's got to be answer choice D. So the question becomes, if you recognize that and then we're working through, how long does this question take you on test day? How long does this question take you? Guys, don't be afraid to talk in the chat. There's only a few of us in this session, so definitely take advantage of it here. Marenki and Cole, I'm loving the participation. Yeah, no time at all. Less than a minute, right? I can fly through this type of question and pick up a nice, quick, easy point. Now, people always ask me before we get into 8, why do simple little questions like this answer? Well, let me ask you guys, what's the reason for being here? Why'd you guys take an MCAT class? Why are we taking the MCAT? Where are we trying to get to? Sometimes I think with all of this information being thrown at us, we forget this notion. Why are we here? Yeah, Marenki, exactly. We're here to go to medical school. But the important part about it is you remember that your MCAT is a means to an end. But if you think about it this way, just a few more questions correct in each section, maybe it's 2, 3 questions. If that brings you up 1 scaled score point in each section, and all of a sudden we just went from a 506 to a 509, a 507 to a 510, you are literally leapfrogging past thousands of applicants in the application process. So it really does matter. Just a few more questions correct, and you guys are taking the best step and most efficient step possible. We're going through a wrong answer choices in a full-length exam that we've taken to try to understand where are these tips and tricks along the way. It's so vital and so critical to your overall success, but the best part about it, it makes you so competitive in the medical school application in the long run. It's a surefire way to see improvement. Now, check this out, okay? If you have triiodonothyronine, or T3, and it's a thyroid hormone that is overproduced in patients with hyperthyroidism. I always think hyper means high hyperthyroidism. What is the correct IUPAC name for T3 as shown in below. Pump the brakes here. If this is the Chem Phys section, do I actually really need to know anything about thyroidism or T3? Do I really need to know anything about it? No, not at all. So if you really go through this, based on this structure and using your answer choices, all of them are actually telling you it's probanoic acid. What's the only difference between the majority of your answer choices here? What is really the difference between them all? It's just that first part, right? So if I look at 2S, 2R, 3S, 3R, but wait a second, based upon this structure, if you have chirality and you're looking for that's based on the structure, the chiral carbon is that second carbon. So just based upon that, what two answers could I eliminate right away? What's that second carbon? Can't I get rid of both C and D just to begin with? That's perfect. Well, now, if I can get rid of both C and D, and I look at this question, then I just have to go through and figure out, was it S or was it R? Well, I can take away from this that I know my nitrogen is going to be the first. This carbon is double bonded to oxygen, and then I have my third right here. Well, if I go 1, 2, 3, and I'm turning my steering wheel to the left, is that S or that R? And I know that I can keep it that way because my hydrogen is going back into the screen because of that dashed wedge. Therefore, immediately, I know it's going to be that 2S. So, did you even really have to know any of your nomenclature in terms of propanoic acid, hydroxy, 3-iodol? Did you have to know any of that information for this question? No. So, Marenki, even if you didn't know that now, that's completely okay. You're going to know that next time you see it, it was just an RS configuration. It's a stoichiometry problem. If you haven't checked out your isomer channel session, that's exactly where you want to go back to. Great thing to see a quick review on this content. Good, excellent. Quick, easy points here, guys, just based on the process of elimination. Now, 30. Any of you guys remember 30 explicitly? I got 30 wrong the first time that I did it, and I was really kicking myself over it. Anyone happen to remember 30? Yeah, Cole, I was kicking myself. I was really bummed that I missed 30 the first go around. Here's why. When you look at it, it says in an exhibition, the fastest recorded pitcher was playing against the batter 60 feet from the pitching mound. If the ball took 0.4 seconds to reach home plate, what was its vertical velocity? Wait a second. If we're thinking about its vertical velocity, well, if you have 60 feet from the pitching mound and it took 0.4 seconds to reach home plate, what was its vertical velocity? Well, approximately how many feet is 5 meters? So this is some information back from your passage, but it's just reasoning here. 3 meters, 1 meter is about 3 feet, so I can approximate that good cold to about 15 feet. And I can think to myself, okay, if the ball took 0.4 seconds to reach home plate, if the vertical velocity was about 5 meters per second, how far would the ball drop before hitting home plate? Well, if we think about it then, in an exhibition, the fastest recorded pitcher was playing against a batter 60 feet from the pitching mound. So if you have 5 meters and the ball took 0.4 seconds to reach home plate, I got to think it's about 2 to maybe 2.4. The exact conversion for 5 meters would be 16.4 feet. Okay? But remember, on the MCAT, you don't have to show your math, so it's great to do a process of estimation here. If the vertical velocity was indeed right about 5 meters per second, how far the ball dropped before hitting home plate? Somewhere between about 2 and 2.4 feet. But does this seem like a reasonable drop? Think about it. When someone, if you like, even think of like a Major League Baseball game, if someone were to throw that baseball, were to drop 2 to 2.4 feet, even if you threw the nastiest curveball or the best breaking ball in the league, is it going to drop 2 to 2.4 feet? Probably not. So if that's not a reasonable drop in height, and we're talking about if the ball took only 0.4 seconds to reach home plate, what's its vertical velocity if I can use the process of elimination here, what's the only reasonable answer choice in this kind of setup? Think about it. 150 meters per second, that's massive. 150 feet per second is still massive. 5 meters per second would be 15 meters per second. You're not going to get that much of a drop. The only answer choice that's even remotely true would be about 0 meters per second. Now, if you think back to baseball and someone does throw that curveball or that breaking ball, then yeah, there's going to be a little bit of movement, but it would not be anywhere close to 2 to 2.4 feet. So did I actually have to do math in a question like number 30? I know there's a lot of aha moments here in this first part of this session, but did I have to do any real math here? Or is it more just the process of estimation? Think about it. It's just estimation. It's a nice, quick, easy answer choice to be able to pick up. Good. Excellent job, guys. Excellent job. Now, question number 39. We're going to kind of flip the roles here a little bit. But I want to walk through this, and I want you guys to think back to what was talked about. Hyperopia, even if you didn't know it, it's going to explain it. But remember, we're in the chem phys section, so there has to be some sort of chemical or physical concept underlying this type of question. Is a condition characterized by an ability to see distant objects clearly, while close objects do not come into proper focus? All right, future doctors, what do we call this? Nearsightedness or farsightedness? You guys remember? What do we call this? Any future ophthalmologists here? Maybe. All right. This is going to be that. Yeah, farsightedness. Absolutely. So it says humans underwater experience a form of hyperopia. What's best accounts for this? Okay, so if you're underwater and you open your eyes, the only thing that's really different here is you're in a different medium. So there's fluid going to be around or on your eyeball. But when I'm going through this question on test day, I'm thinking to myself, all right, this has to still be related back to chem or phys. So we have refractive indices, we have light rays, but what I know is I'm going to a thicker medium in water or a thinner medium. Is it a thicker or thinner medium? So we want to think about light here, right? It's got to be a thicker medium. So you can ask yourself then, they're not similar. The refractive indices of the waters can't be similar, so I can just get rid of B based upon common knowledge. Then, if you think about the refraction of the light, what happens is the two substances with different refractions, light is going to bend. So the refractive indices of the water and the eye, well, can you use your answer choices to your advantage here? If there is insufficient refraction of light, what can we say about the relative refractive indices? Are they going to be similar or largely different if this is approximately the same sort of form of hyperopia? Are they going to be similar or too different? Oh, you're absolutely right. They're going to be similar. The only answer choice that's going to make contextual sense here has got to actually be answer choice A. The refractive indices of water in the eye's media are too similar. So that's the only way that's going to account for humans underwater experiencing that form of hyperopia. Okay? Excellent job here, guys. Excellent. So what we noticed, and we can go through one more question here with question number 43, excuse me, we'll do a couple more questions here, is that the process of elimination is going to be huge, especially in the chem phys section. What do you guys feel like a strategy from perspective helps you out with the process of elimination? So I always ask this question a little bit differently. Does anybody feel like at some point during their process of going through their full length exams, you feel like, man, every single question, I know that I can eliminate 2 answer choices, but I'm usually stuck between a 50-50. Anybody feel that way? It's like you always get it down to 2 answer choices, and you're like, ugh, what happened there? Okay, cool, I totally did too. Sometimes it's better to just go through and say to yourself, instead of being able to choose the correct answer, could I eliminate one of the other answer choices? So check this out. Tetrodotoxin is another toxin that can be deadly. It acts by not allowing sodium to pass into the nerve cells through the channels. Okay, well, if you think about it, what likely effect would this have had on the membrane potential during action potential? if I go through this type of question, I want you guys to get an insight into how I would do this on test day. Don't overthink a question like this. What it's telling you is it's not allowing sodium to pass into the nerve cells. But what I remember is there's a higher concentration of sodium outside the cell than there is inside the cell. So that would cause my rapid depolarization through the action potential. So can you depolarize enough to reach threshold? Absolutely not. So, but remember, what is the question asking you here? What likely effect would this have had on the membrane potential during an action potential? Well, what would happen is it would never depolarize. So it would end up remaining approximately the same. If your sodium doesn't rush into the cell, do you ever get to hyperpolarization, depolarization, or repolarization? Would you ever actually get to those steps within an action potential? No. So in this case, just by a quick process of elimination, boom, I can pick up answer choice C and I'm good to go. Now I'm starting to gain excitement and momentum because I'm able to pick up quick, easy answer choices in a nice, efficient method. Now, let's jump to 54. This is another great example of a question that I did not like the first time going through. Anybody happen to specifically remember 54 going through fully 5? Okay, I got this question wrong. This was another one of those questions that I'm definitely not happy that I missed. Okay, differences in sodium ion concentrations across the membrane are a major determinant of membrane potential. Okay, so Maranki, you saw the trick then, which I'm super pumped to see that. It says which of the following are likely values for the first and second ionization energies respectively for sodium. I made a silly mistake here, but think, guys, all right, if you make silly mistakes, aren't those actually just quick fixes later on when you're reviewing? So it's always good to think to yourself, if I make a silly mistake, I'm not going to say the same silly mistake again. But as soon as I look at this, what's the one answer choice that sticks out from the very beginning that I know is just simply not going to work? Think about it. There's one answer choice here. Why would the first and second ionization energies be the same? I'm very suspicious of answer choice A from the beginning. But then I'm thinking to myself, okay, if I have sodium on the periodic table, are things on the left side of the periodic table relatively easy to ionize? Are they relatively easy to ionize? Yeah, you betcha. Love it. So is my first ionization energy going to be bigger or smaller than my second ionization energy? Remember, ionization energy is just the amount of energy it would take to pull off one electron. It has to be relatively smaller. Well, the only answer choice that's going to be relatively smaller, or the second ionization energy to be higher, is C. And I'm done. Was there any calculations here in question 54? So Maranki, I made a really silly mistake there. And I always tell students, because I don't want you guys to think just because we're Kaplan teachers that we like magically or just know everything immediately. We take the same questions you do, and sometimes we make silly mistakes. I'm never going to make that mistake again, especially on a question like this, but it happens. You need to make sure you always go back and think about your fully 5 reviews as a means to an end. This is just the process of learning. What's cool about this is when you're working through, you can see this come up over and over again. Same pattern or trend. Now, check out 56. I love questions like 56. Originally, when people get to questions like 56, they think to themselves, all right, do I have to know things about these? Quinone and hydroquinone? Well, I mean, who knows? Which of the following occurs during this reaction? But wait, if I look at all 4 answer choices, what do they have in common? Well, the answer choice is, it says they lose 2 electrons and gain 2 protons, gains 2 electrons and 2 protons, loses 4 electrons and gains 2 protons, or gains 4 electrons and 2 protons. But wait, if I just think logically about this, is there any change in charge between quinone and hydroquinone? Is there any change in charge between? No, they're both neutral. So if they're both neutral, then if I gain 2 protons, what else do I also have to gain? It's just logic, which is so cool. I love questions like this. What would I also have to gain? If there's 2 and 2, it's just got to be 2 electrons. Boom, done. Quick, easy point. Moving on to my next question. This is where it becomes awesome, guys. It's a nice, quick process of world elimination. So this brings us into learning goal 2, which is great. And I'm really a big fan of learning goal 2 because what we're going to see here is how can I actually use or go through certain questions that at first glance might make me seem like I have to do a lot of math or go through a mathematical process, but in actuality, it's just a nice, simple, quick process of elimination by manipulating mathematical formulas. Like a question like number 4, for example. Now what I'm going to do for a few of these questions, and I want you guys to make sure we're using the Q&A as a process to ask questions, I'm going to show you guys and walk through these questions, and I'm going to do 4 questions here, okay? Exactly the way that I would do them if I were going through on test day. So this is kind of like an inside look, as if I was doing this right now, how you would see my own thought process work through with the questions on it. Yeah, Mikey, and I like to do this in my classes too, because I think it's a good way for people to see, okay, well, if someone who was good at the MCAT is going to go through and do a few questions, what's like an easy way to see, or what would be your thought process when working through? Now, some of the stuff that I say might sound kind of wacky, like I'm talking to myself, but I want to give you guys an insight as if to while I was taking the test, what am I thinking? So if anything that I say or the background content knowledge that I'm bringing up doesn't make sense, that's exactly what I want you guys to ask Chuck in the Q&A. Okay? So there's not a ton of people in this channel session. I won't want you guys to be afraid. Ask questions. But I want to give you guys kind of an inside look. Sometimes it's fun to do when there's less people in the room because you guys can see a little bit more. So 4. If I got to a question like number 4 and it says, at constant pressure, the ratio between the volume expansion of a mole of gas with a high C to that of a mole of gas with a low C for a given heat input will be what? Well, remember, I just looked at this passage previously. I'm thinking to myself, CP and CP. All my answer choices are greater than 1, less than 1, or equal to 1, or cannot be determined. I'm very skeptical of D to begin with, but I know that there's a formula from the passage that was Q equals NCP delta T. But it says at a constant pressure, the ratio between the volume expansion of a mole of gas with a high to that of a mole of gas with a low, I need to adjust accordingly. But what I do know is that there's got to be a relationship between C and T, and I got to think back to, okay, PV equals nRT. If I increase pressure, then I have to theoretically be increasing temperature if everything else would stay constant. Ah, this makes a lot of sense. If this is an inverse reaction, it's playing against the same mathematical relationship. So if temperature and volume are related that way, I know that I already have an inside track with this question. Temperature, right, PV equals nRT, it's direct. Well, if it's direct, I'm done. It's got to be less than 1. There's no other way to look at a question like this because I'm just taking a really quick shortcut here based upon what I already know. If I'm working through this on test day, I know they're directly proportional. So the greater the change in temperature, the greater the change in volume. Thus, the gas with the high CP value will expand less than the gas with the low CP value. But remember, if I'm looking at this question, if it's CP over CP, or the high over the low, then that value for that given heat input would have to be less than 1. Boom. Quick, easy question. I'm getting a lot of momentum in this and confidence. Okay. 13, if I got to a question like 13, potentially I'm going to skip it on test day and come back to it later, thinking that I had to do math. However, once I get to this question, I'm going to realize I didn't actually have to do as much math as I thought. Carbonic acid. I know carbonic acid is a great physiological buffer. I'm feeling really confident when I read this question now because I've seen stuff like this before. Now, the change in the pKa divided by the degrees Celsius for carbonic acid has been calculated as a very small negative number. Based on this information, which of the following is always true about the dissociation of carbonic acid? Now, wait a second. If my pKa is getting smaller, this question is actually super straightforward. The pKa is getting smaller, what's happening to the Ka? Ka is increasing. I know that's an inverse relationship. I know my basic gen chem here. So if my Ka value is increasing, I always remember, or I think to myself, if I have any sort of Ka, Ka is a measurement of the concentration of products over the concentration of my reactants, right? So if that's there, that's already inside look, I know that the more dissociation at higher temperatures. Now, if I bring that through, and I'm thinking which of the following is always true about the dissociation of carbonic acid, then don't I need to know if I shift to the right, then there's more heat needed. you have to increase the overall amount of heat or the temperature in order to go through. So in this case, if you shift right or more heat is needed, what answer choice here corresponds? Done. Heat enthalpy. One of the things that students most commonly do here is sometimes we make silly mistakes. S is entropy, H is enthalpy, G is Gibbs free energy, and I know that I don't have anything to do with pKa here. So is this a hard question on test day? Or would this be a difficult question on test day? No, not anymore. You're exactly right, Cole. So I always like to show you guys, kind of giving you guys my thought process, because it kind of shows that, hey, you have to see Marenki, and exactly, that's the thought process that I'm trying to convey to you. Anytime I do a full-length review in my channel sessions, okay, I always tell students, I don't care if we bring up every single question that you got wrong on test day. I want you guys more to start to understand the strategy behind this, because what it shows you as the critical thinking of combining concepts is what's key. And if anything, if I just leave you guys here getting a little bit more excited and a little bit more motivated of seeing that, it's not about just going through and blindly reading review notes. I want you guys to answer questions. I want you to make mistakes. You guys are thinking, what on earth are you talking about, dude? But making mistakes is a good thing. Sometimes as we're going through, you think to yourself, oh my gosh, in this crazy pre-med world, there's this like obsession for perfection. Well, guess what? You're not going to get that awesome score until you admit to yourself that, hey, I'm going to get questions wrong in the process. I did not see the huge increase in my score until full length 5. But then I started to see massive increases because things started to click. This, my friends, is what it's all about. So let's take a look at another one. Okay? Norepinephrine, but I know I'm still in chem phys, so this has got to be a chemistry type of question, causes constriction of blood vessels. I constrict blood vessels, my blood volume is moving pretty fast. Okay, pressure is probably going to go up. If a certain blood vessel is constricted to half its diameter, yet maintains the same pressure gradient according to Massu's law, the flow rate is expected to do what? Okay, I actually gave you guys a really quick answer to this, but this is an actual equation. What commonly ends up happening here is people make a significant mistake. That mistake revolves around the equation. Okay, the equation is Q equals delta P pi R fourth to the fourth value divided by 8 mu out. But here's the thing. What would we predict the change in flow rate to be in this particular case? If a certain blood vessel is constricted to half of its diameter, how do we relate that to radius? It's got to be half of the radius it had before. Q is proportional R to the fourth, so if R is reduced by half, then Q would be just reduced by 16. Is there that much math in this problem? Not a crazy question, but it's just quick math. Yeah, and Renki, it's always confusing to really anyone, but this is a type of question that when you get to it on test day, okay, it's tough when you're working through this because you need to make sure that you understand how the variables manipulate. Let me show you one that's actually super similar. Remember question 50? This is actually the exact same type of question. Anybody remember 50 from their test? It's the exact same type, but what you remember is this as a capacitor. Now we're changing our subtopic, but it's still the same type of strategy utilizing this process of manipulating our equations. A capacitor containing two flat parallel plates separated by a vacuum is connected by a battery with a voltage V. Then its plates are pulled apart to a distance double the original one. Okay. But by what factor does the energy density between the plates change? Well, this is easy. If we double the distance, what happens to capacitance? It's just an inverse relationship. If you double, you decrease by 2. The equations you can use, okay, U is going to equal U over AD, or U equals CV squared divided by 2. When I plug those things together, then I remember that's that inverse relationship, and all I have to do is match by, because if you bring that squared value in, an answer choice D, 1/4. So again, when you bring this in where V is volume, okay, and in the second equation you have AD in the denominator, so V in the numerator is voltage. What happens there is you're relating volume with voltage. That's one of the things that people most commonly confuse when working through this type of question. Okay, good. So it's just equation manipulation to give you the overall factors that we're working through. Now, question 51 rolls into the same type of thing. We're still talking about capacitance here, but notice how this changes completely. It says, what could account for the difference in capacitance per area between myelinated and unmyelinated axon? Guys, what's the difference, or what do we remember the difference is between myelination and unmyelinated? What's the difference between those two things? Remember, myelinated are going to be what? What do they have around their axons? So you notice there's a huge shortcut here. Think, think, think. Sometimes myelinated, it's insulated, right? So if it's insulated, theoretically, you're already starting to create a capacitance in a way. But what happens, really the only thing that's different between your myelinated and unmyelinated is the thickness that you have. So the equation that we get is capacitance here is equal to EA divided by D. Now, what happens sometimes is if you did not know this equation, right, this question becomes a little bit more difficult. So it is, in a lot of ways, the MCAT does reward the student who does remember their equations properly. But taking this into account, what variable in that formula changes when the myelin sheath is present? Well, if you're wrapping something around, it has to be that D, or that distance or thickness around. So if you increase that thickness, what would it do to the overall capacitance that you have? Okay, well, it's going to decrease it. So if you really look at the questions, myelinated axons are longer than unmyelinated axons. In unmyelinated axons, the lipid bilayer is thinner. Myelin decreases the membrane potential, and unmyelinated membranes have a higher resistivity. Well, D, not necessarily. They're both relatively the same. C, a decrease in membrane potential would increase the capacitance. That doesn't make any sense. So just based off of common knowledge, I can go to B. Did I actually have to go through, or was there potentially a shortcut with my equation here? You could have gone through and used that shortcut. Just by going through the process of elimination, sometimes you do not have to go through complete variable manipulation. Excellent, Anki. Good. Excellent job. So what this brings us into, we've got about 15 minutes left here, is learning goal number 3. Now, how many of us, when thinking back specifically about orgo, just do not like organic chemistry? I know, completely understand, but organic chemistry is just not your favorite. Yeah, I used to have nightmares, right? You walk in, I used to have a nightmare that I'd be like walking into a classroom and I'd have to teach back a mechanism, and then I'd be in front of a group of like 100 people and I couldn't talk. I became a mute and I wasn't able to do it. It's like the worst nightmare ever. So that I couldn't be able to write out the equations on the blackboard because hundreds of people were screaming at me about organic chemistry reactions. I know, it sounds like the most crazy pre-med nightmare ever, but it happened. So in this section, what we're going to do, how can we apply our knowledge of functional groups and nomenclature to just pick up quick questions? The best thing you can do for organic chemistry in this process is just go by going through, and utilizing your quick knowledge to pick up easy points. Like a question like number 9. It says, if the final product of the reaction formed in step 6 is heated, what compound would be obtained? So if I think back to question number 9, this is one that would be a good review if you can just think back to it. The key to this question was just to identify the type of compound you had in compound 6, right? So, or excuse me, step 6. So when you have this here, you look at it, you think to yourself, well, okay, if I see something there, I got my OH groups, my carbonyl groups being formed, and I got this ring coming through, but in this final product of the reaction is heated, what compound will be obtained? Well, what type of compound is the product? It's a hydroxyl ketone, right? If you see this here, a beta hydroxy, my OH, ketone. Well, that makes sense. Now, if I were to heat that, what happens to those compounds when they're heated if you have a ketone? You just have to have a dehydration reaction, right? But the only answer choice, just based off of that quick knowledge of my nomenclature, has got to be answer choice D. What's your byproduct from a dehydration reaction, guys? if you're going through a dehydration reaction, what would you not expect to be present would be a hydroxyl group. So wouldn't you have to see a water in that space? Rankin, you're absolutely right. So you look at questions like this that are designed to be so complicated, but in actuality, it's not that bad, okay? So you really could utilize this to your advantage, okay? Excellent job here, guys. Now, this we picked was one of the more difficult passages that you guys had on this full length. It was passage number 7 in this section. So what I want to show you guys is a quick review of how I would go through and say, hey, I want to get into this passage as quickly and as efficiently as possible. So what I like to call this is to kind of cut and run, all right? When I went through this, I was not overly outlining anything. I might just write down phenols. I got synthetic and natural, properties and their derivatives. I talk about the ID test, and then maybe a little bit the student had to ID some unknowns. But I don't want to over outline, and I don't want to spend too much time because it's a waste of time in the long run. There's too much of an aspect with timing here. I want you guys to leave today thinking this is more manageable. Just do a quick outline. And it gives you now the different tests. So test 1 was just a solubility test. Talk about water, NaHCO3, sodium hydroxide. Test 2 is my oxidations, talking about Toland's reagent, the chromic acid. And test 3 was our ferric chloride test. So even if you didn't know everything about these tests, get in and work as quickly and as efficiently as possible through this. I'm only going back to information from the passage if the question asks for it. Don't run out of time trying to go through and stay bogged down in a passage like this. It's just not worth it in the long run. So I have a ton of information in my tables, okay? I have the molar mass and pK for unknown compounds, A, B, C, D, and E, noticing that D is probably my smallest, C is going to be my largest, right? In my unknown compounds, it says the summary of the student's observations. Compound A, B, C, D, and E, and it gives you the numerical values as present. So test 1 results and the molar mass, I'm good. Then I get into the summary from test 2 and from test 3, whether I had the precipitate, the chromate color, and then the solution color. Good, cut and run. Do not spend a lot of time. Note where it is and get into the questions. Okay, so what we're trying to show you guys here is I want you guys to leave Chem Phys review tonight. You want to be able to go through and use that cut and run. I don't want to spend too much time in passages that are simply going to take me too long to be able to work through. Okay? Now, looking at question 31, this is a Roman numeral question. What Roman numeral statement shows up most common in my answer choices here? Which one shows up most common? 2. Excellent job. So when I see these 2 here, it says comparing the Ka values for cyclohexanol and phenyl reveals that phenyl is more acidic than cyclohexanol. What do I know about phenyl group, though? There's one major thing I can remember about the phenyl group. Isn't that a conjugated system? So it's going to hold more electron density. So the major structural difference that I would notice right away about that phenyl group, if it's a conjugated system, I have a relatively large difference in my Ka values, right? So think about it. Ka value is much larger for the phenyl group. So is phenyl more acidic or less acidic than the cyclohexanol? Well, what it's saying, and this is the question's already giving it to you, the phenyl would have to be much more acidic. Just think of your Ka values. Concentration of products over the concentration of reactants. Higher products, it's got to be more acidic. So which of the following would explain the acidity of phenyl? Well, in this case, think about it. If I go to 2, phenol's conjugate base, phenoxide, is stabilized by resonance to a greater extent than the phenol itself. Well, yeah, it would be, because if it's a conjugated system and I get rid of that, I'm able to stabilize that charge. That helps me get rid of statement 1 first. Then I would go back to statement 3. The negative charge of the oxygen atom on the phenyl oxide ion is delocalized over the benzene ring. Absolutely. 3 is definitely to be true. So I can get rid of B. The key to this question was statement 1. The exceptionally strong hydrogen bonding possible with phenyl facilitates the loss of a proton. But alcohols have hydroxyl groups or similar hydrogen bonding. So would 1 really explain the acidity difference between the phenyl group? Think about it. Is that a large difference between these two structures just based upon our overall functional groups? Is that a major difference to explain the difference in acidity? Both of them are able to hydrogen group. Exactly. So if they're both able to hydrogen bond, boom, I'm done. I only got to choose answer choice C just by a quick process of elimination. Good. Excellent. Nice. We're seeing some easy points here all the way through. Okay, let's pick this right up in question number 32. What simple chemical test could be used to distinguish between the following two compounds? Wait a sec. Is there a significant difference between 1 and 2 here? Don't be afraid to type in the chat, guys. The main difference between these two, well, the phenyl OH and the alcohol OH. Wait a second. If I work through this, to deprotonate a weak acid, what kind of base would you need? A strong base, right? So if we really look at between compounds 1 and compounds 2, the main difference between these two structures, compound 1 is a phenyl derivative, whereas compound 2 has that benzene ring. The hydroxyl group is not attached, so it has properties that are going to be more similar to that aliphatic alcohol. The passage told us that phenols are more acidic than their aliphatic counterparts. However, they're still weak acids. So if you would need a strong base, like something like sodium hydroxide, then what I know here is I can actually very quickly match to answer choice B. Compound 1's solubility in aqueous sodium hydroxide. I would need something that's going to give me a strong base overall. So a strong base will deprotonate the compound in 1, but it's not going to affect compound 2 since it's not as acidic. Thus, compound 1 would have a negative charge and would become more soluble in that aqueous solution. Okay, so you'd expect to get only 1 layer for compound 1, but 2 of those layers for compound 2, thereby matching to answer choice B. All right, okay, good, excellent job. Okay, now jumping into 33. 33 is another test question. But to answer this question, you got to analyze the data present in the various tables and predict how the phenyl would react and compare it to the results from the experiments. So this is a tough question because it says the student concludes that from her observations that compound E is a phenyl. Is her conclusion correct? Well, think about it. What's the pKa for phenyl? This question initially appears kind of tough, but it's not as bad as it originally appeared to be. It's approximately around 10, right? So the molar mass in the pKa for the unknown compounds. Is this a phenyl group? Are those answers matching? No. Well, guess what? Boom. I got rid of A and B right off the bat. That's awesome. So again, using the same strategy we talked about earlier, but now we look, if C says because compound E is less acidic than compound C, or because compound E showed a negative result with chromic acid. Well, if we go through this and you just go back to your basic part, you got to ask yourself, what is the difference between chromic acid and Tollens reagent? Well, chromic acid is a strong oxidizer and can oxidize alcohols, whereas Tollens reagent is a weak oxidizer and can only oxidize aldehydes. So if compound E did not react with chromic acid, it's completely oxidized and cannot react with phenyl. Therefore, it's got to be answer choice D, as in dog. Good. Excellent job, guys. So what you can do here is we can pick up quick answer choices working through. Okay, question 34 here. Now, the student concludes from her observations that compound A is a tertiary alcohol and compound D is a primary alcohol. What additional piece of information supports her conclusion? This is great. If you've seen this before, guess what? Primary and tertiary alcohols react with an oxidizing agent. Primary forms the aldehyde, or carboxylic acid. Tertiary doesn't react. Well, wait a second. If compound D is the primary alcohol and compound A is the tertiary alcohol, then compound A, it's got to be answer choice A. Some of you guys are probably looking, wait a second, how did you answer that question so quickly with 34? But think about it. The question is really asking, how do primary and tertiary alcohols different or react differently? tertiary alcohols aren't going to react, right? So if you think about it, depending upon the strength of the agent, a primary alcohol can either produce that aldehyde or it's going to go all the way through to that carboxylic acid. Tertiary alcohols, on the other hand, are already oxidized, so they can't react. So if you go through and think to yourself, compound D functioned as a reducing agent, well, compound A didn't. That would suggest that the student's hypothesis based on the passage would in fact be true. So D would be a reducing agent. So Marenke, ask yourself this. If D is a better reducing agent, does a reducing agent become oxidized or does it become reduced? This is the shortcut to this question. If you're a reducing agent, you become oxidized. Hence, then, the only answer choice that's even giving me that clue has got to be answer choice A, because it would be oxidized overall. Okay, is that better? Just a nice, quick shortcut in a question like 34. Good. Excellent job, guys. Very good. Okay, one last question here with question number 41 to finish up for tonight. Okay, it says, which of the following acids has the weakest conjugate base? Okay, anyone see these questions and kind of shudder because you think to yourself, ugh, I've seen these questions come up time and time again on my practice test, and I miss them every time just because I'm making a silly mistake or working through. Okay, now I know I did the same thing, but when you see this here, if you look at a question like 41, which of the following acids has the weakest conjugate base? Ranky, that's exactly what I want to leave you guys with here tonight. When you see something like this, you have to ask yourself, what would increase the acidity of a carboxylic acid? If you are becoming more acidic, what do you have to have the ability to do once you donate that hydrogen? Once you donate it, what do you want that compound to be able to do? Think. The conjugate base has to be able to stabilize what? What does the conjugate base have to be able to stabilize? The charge, right? Because if you're donating that proton away, we have to be able to donate the charge. So if you want to be able to readily accept that charge, would you want more electron withdrawing groups or electron donating groups? Think about it. Would it be more electron withdrawing or more electron donating if you have to stabilize that negative charge? Withdrawing. Very good, Cole. So if it's electron withdrawing groups, you just got to go through these questions and ask yourself, okay, what atoms or groups will pull away electron density? Halogens, right? Oxygen, nitrogen groups, anything that has greater electronegativity overall. Well, what's the only answer choice here that actually has electron withdrawing groups compared to the other three? You can notice it right away. I always look for halogens first, because if I see halogens and no other one has halogens, I'm done. Answer choice D is the only one here that has halogens. Good. It's a nice, quick, efficient method to be able to work through. You guys can see it right away. Okay? So, guys, I want to thank you for another great full-length review. All right, I know a lot of you guys were asking questions in the chat. So, Neem, Ranky, Lindsay, Cole, Alexander, Michelle, I want you guys to wish you a very, very good rest of your full-length review. Yeah, and it really is. And even if you guys were going through, and I know we worked through these a little bit quicker, and you think to yourself, man, I just need to go through and review that content, remember, that's a good thing. Just quick content review is much easier to go through than your overall strategy. You guys have been working your butts off for this strategy, and that's what's really going to pay off on test day. So remember, any mistake that you guys make is really just another thing that you can pick up or a pattern you can recognize later on to continue to see that improvement. So I got my best friend John Liddick coming up with a CARS full-length review for 5 right after this, and I want to leave you guys as I leave every single MCAT channel session. Remember, mistakes are good because success is just one preparation meets opportunity. Have a great night, guys. I hope to see you guys back here in the channel session soon. I'll stick around in Q&A if you guys have any other questions for me. All right? We'll get back here shortly. John, full-length review 5 and CARS. Have a good night, guys.